Bismillahirrahmanirrahim. Here we have distributed database. A distributed database, you can think about a collection of databases in which every database is separated from one another, but they are interconnected with one another by some conceptual schemas. Okay, a distributed database is an integrated collection of database that is physically distributed across the sites in the computer network. A distributed database management system is a software system that manages a distributed databases such as distribution aspects are transparent to the users. To form a distributed database, files must be structured logically interrelated. Means all the databases that are distributed physically must be interconnected and must be logically connected with one another across the network. So if someone else or some end user wants to store some data or wants to access or retrieve some data, then he or she can do so in an easy manner. Right, so we have two types of databases, homogeneous and heterogeneous. In homogeneous databases, we have same type of database data in all over the database. Okay, just like student management system, we have same type of data all across the databases, and in heterogeneous database, you can say in Google management system. Google itself a management system in which we have heterogeneous type of data. You have some research data, you have some storage type data, you have some personal type data that is stored over the servers of Google and are using the logical connections of Google database. All right. Features. It is used to create, retrieve, update, delete distributed databases. Basically, the operations are CRUD operations. Do you know about CRUD operations?
No, sir. I have no idea about this.
Okay. Basically, CRUD operations are, you can say, creating a record. For C is for creating a record. R is for reading or viewing a record, or you can say a viewing a database design. U is for updation inside the database design or inside that database tuple. Tuple for tuple, you must have some valid data that is present inside of your database, and D is for deletion. For example, if you want to delete, update, create, or view some operations inside your database, then you have to do so. And these operations is also called CRUD operations. Okay.
Okay, features you can use CRUD operations. It is synchronized databases periodically. For example, you can determine the period of updation or synchronization. Let's say if you want to make a period of 1 day, usually developers makes the synchronization time for 5 hours. Okay, 5 hours is the standard time. That is professional in the IT industry, but you can set it as a 24 hours and provide access mechanism by the which distribution become transparent to the means you have some access, then you can also provide some access, some controlled access to someone else. Okay, by term of controlled access, I mean, for example, I ask you are the database administrator. Okay, now you want to give some limited time access to your colleagues, then you can do so. In this way, you have to just uh, write queries for giving access, or you can say user authentication to someone else with their emails, and then you can set up the time period of 5 hours or whatever the time you want to set for limited access control. Okay, then you can do so in this way. It ensures the data modified at any site is universally updated. For example, if you want to update a data in some instance of student, then it will be updated throughout the database, whatever the database location that is available to you. Okay,
Yes, sir.
guys, if you have any query, then you can ask.
No, sir.
All right, you can also maintain the data integrity within your system or within your database management system. It is totally up to you. Factors encouraging DDMS: distributed nature of organizational units, need for sharing of data, both support for both OLTP and OLAP. Basically, OLTP is usually, you can say, used in banking systems. OLTP is usually used in banking system or in ATM systems or online payment transaction system. Okay, just like PayPal, just like Swift, just like Stripe. Okay, and OLAP is usually used in labs, in data science, in big data. Okay, while you have some big data of trillions of tuples, and you have some operations to do over the record, then you are using OLAP system. Okay, need for sharing of data. For example, Google is the enrich and big and obvious, it's a big data system, and it is a data center. Actually, it is a data center through which you can access any data. Google developed its browser, Chrome. Google helps to develop many others web browser like Firefox, like we have Windows Edge. Okay, so these are the products of Google's that is used to search many data that is present across the network of databases. Basically, Google ensures you I have a complex database management system that stores the data, that stores some files, that store your personal data, that stores some information, and that can store each and everything that will be helpful in your life. Okay, now you have a need for sharing your data, or you have a need to store your data over the cloud, and that data must be accessible all over the world at any time, at any place, right?
Yes, sir.
Yes, sir.
All right. For example, if any one of you stores your data over the Google Cloud or over the Google Data Studio or over the Google Space, okay, that is 15 GB and connected to your Gmail account, I think so, right?
Yes.
All right. You upload your cell phone's data over the cloud and then close the connection. If you are traveling outside of your country, then you can access that cloud data or that account data through any part of the world at any time by just logging into your account, by just sharing your data with Google. In this way, you share your data over the distributed network of databases, means Google, sorry. You share your data over the Google Cloud. You share your data with some complex DBMS. So this is how Google is catering the need of sharing of data all over the world. Distributed nature of organizational units. For example, if you have an organization, you are the owner of or an organization that head office is in Jeddah. There's branch offices are all over the world, and these all branches have some database management systems in their respective areas. But the central database management system is installed into your Jeddah office. Okay. Now, your organization is distributed in all over the world by its branches. So they can access the local data within the database system that is installed in their respective places. But they can also request and can access the data that is stored in the central database management system that is installed into your JDS office. Okay,
Yes, sir.
Yes, sir.
all of you.
Yes, sir.
All right. Database recovery. One of the common techniques used in DDBMS is a replication of data across different sites. For example, in Wikipedia, whatever the data that is present belongs to the Harvard University can be can be replicated into some other universities. For example, Harvard University have some 13,000 students in the respective campuses. Then also we have some universities that has some other campuses that can cater the amount of students in the respective areas. Okay,
Yes, sir.
Yes, sir.
all right. For example, if we have 1500 tuples of data that is present in some other universities also can be present in some other university campuses, and if central data center gets offline while purifying some data within its branch offices or branch campuses, then it can be recovered by some other type of data resource. You can say you have a copy of your data into your branch offices. Okay, and that branch can be the same university, can be some other university, because we all have in the idea of cybersecurity, right? For example, if a university is on the cyber alert and their data is on risk for getting being hacked, then that university can store the data. Okay, can store the data into some other university database management system, or you can say a central database management system files. And if unfortunately that university lost the data and lost the connections of all DBMS, while is it in branch offices, while is it in it's in central offices, then they can retrieve their DBMS, the whole DBMS or the application of DBMS while requesting that specific data. It is the same as we replicate our data into Google Cloud, and then we can retrieve the same data whenever we need at some different account. Support for support for multiple application software. Distributed databases can support different application software. In modern world, MongoDB is the example of distributed database management system and is widely used in web applications. Why? Due to its structure, due to its fast performance, and due to its support across the web application and the connection history. Okay, if you have any query, then you can ask.
Sir, I want to ask something.
Yes, sure.
You said 1500 tuples or something. This tuples is unit for data or something. I didn't understand. What's the definition of tuples?
Okay. Basically, tuple is a row of data in an instance, or you can say in a table. If there is a complete row of data, then you can call it as a tuple. Okay. The basic property of tuple is tuple can neither be empty and can neither be duplicated. Okay. Or can hold duplicate data. Okay.
Yes, sir.
For example, if an instance is redundant, okay, redundant means it has some redundant data. A table has some redundant data. Redundant data, by redundant data I mean there is no duplication of data in that table. Okay, every data is singular and every data belongs to a singular attributes. Okay, so every row or every records in the table is a table. Okay,
Yes, sir. Got it.
all right. Advantages of distributed database. We have some advantages, means modular development, more reliable, better response, low communication cost. Modular development, for example, while we are developing a distributed database management systems, then we can develop it by modules. For example, first we will develop login modules, right? Then we will develop the core instance module. Core instances are, for example, let's take an example of student management system, okay, or a university database management system. In university database management system, we have three key instances, okay, teacher, student, and administration, right?
Yes, sir.
All right. In all three instances, we have the instance of student that is on the number one priority. Why? Because basically we are storing the data of students along with the names of teachers, right? And also along with the names of courses that is allowed to the respective students. So by modular development, we can develop the module that will be deal to store the data of students. Then we can go on the priority number two. We can store the data of courses or teachers. Then we will write code or we will write queries for the development of courses module or courses teacher modules. Okay, this is how, while developing the database, when you are going to develop it by module, then you can say you are developing that distributed database management systems. Okay, it is more reliable. Why? Because it can handle a lot of load. It can handle a lot of queries at 1 second. For example, MySQL can handle 1 million requests in 1 second. Then distributed management system can hold 10 million. Better response, it can respond better. Why? Because the search timing and the search algorithm that is used in data distributed database management systems are much better than MySQL. MySQL search while using key records or by using key attributes in the entire instance. But in distributed database, your every data file will be distributed and placed in some distributed areas. For example, if your file is present on the rack number 16, then it will take only the 16 number rack as a key value and directly go there. and fetch out the desired result, means desired data, into the instance and show it on the display. Got it?
Yes, sir.
Yes, sir.
All right.
Yes, sir.
Hierarchical database. By hierarchical database, it is a clear picture that a database structure will be in hierarchy form. For example, tree is the best example for hierarchical. Okay. The main thing is root. Root, you can say, is an admin. Okay. Through admin, you can travel in any branch or in any leaf part of the database. By branches and by leaf, I mean there is an instance called teacher. Then the branch is the attributes of instance, for example, ID, name, status, course holding numbers, salary, age, and whatever the instance attributes that holds by instance. Okay. And now leaves. Leaves are some data that is present or that is stored into that branches. For example, ID holds the ID of teacher, name branch holds the name of teacher, salary holds the salary type data. Okay. And these all data types and data models can be accessed by admin. Okay. Or you can say a root, or you can say an instance name. So you just have to fetch out an instance name. By instance name, I mean to say table name. Okay. You can also call instance a table. All right.
Yes, sir.
For example, your family history inside a government management system, or you can say family management system, family information management system. Your family has some specific ID. In that in that ID, you can say it, um, your family number is a branch name. Okay. Or you can say a branch number. In that branch number, how many leaves data are there? The leaves data are the person's information. For example, my family holds five members. Okay. Now my family numbers got five leaves data inside of their hierarchical database. While developing a hierarchical database, when it comes to the family instance, or the instance that is belongs to family information, then it will hold family number, family name, family member. Okay. And then it will be directly or indirectly connected to members. Basically, the hierarchy of structure is look like this. First, we have level 1 child, that is family or family number. In the family, we have some other level child, means persons that is present in some specific family. In data modeling or in data science, while we are dealing with data, then we call each level of data as a root for its next generation data. For example, if we are on level 1 child, then it will be the root for level 2 child. It will be the root for next level data. The next level data is level 2 child. The root for level 2 child or the next level data is level 1 child. Okay. In this way, the hierarchical database will get formed and data will be stored in the same hierarchical manner. When request comes, It just put us the root number. Means, for example, we have some root number, means we have some data organization. The organization is HNIT. Then its next level data root. Next level data is level 1 child. It is the class of relational database management system. Okay, that data is stored on the level 1 child. Level 1 child is the family name, means database management system, relational database management system. Then now it is the root for the next level data. This family holds these type of students, these number of students. For example, we have five number of students: Ayas, Mujahid, Rania, and me, and also some two others. Okay, we have 7 or 5 students that is present or that belongs to relational database management system family. So our root is, our data is stored in level 2 child. Our root data, that is relational database management system, is stored in level 1 child. Our the main root data, for example institute data HNIT, will be stored in main root level data. Is everything clear?
Yes, sir.
Yes, sir.
All of you?
Yes,
All
sir.
right. We have some advantages. A user can retrieve data very quickly. Similarly, we have some disadvantages. When user want to store data into child table, means in the child or in the child of that root, then it can, and he must be stored the data into the root address. For example, if I want to store the data of relational database management system into level 1 child, then it is necessary for me to incorporate or store the data of my root, relational database root, into the root of that specific instance. Okay, and that root is HNIT. So for example, if you want to store the data on level 2 child, then you must store the root data first. This is the main disadvantage. Similarly, the referential integrity is built in and automatically enforced, due to which a record in a child table must be linked to an existing record in a parent table. Means you must have to store the data first in the parent, second in the child. Okay, and by referential integrity, I mean there should be one data present into the instance. Okay, there should be one data at one time present and interrelated with one another. There is no duplication of data present in the hierarchical database model. Okay,
No, sir, it's clear.
network database. Basically, in network database, every child can have singular or multiple roots. Okay, this is in network databases. We have the core concept. The core concept is, if you want to store the data into child, then you must check the parent data or the parent nodes of specific data. Okay, network database management system are based on network data model that allows each record to have multiple parents and multiple child records. Okay, but first you must ensure that you know about the parent. Okay, you know about the parent of this parent of your specific data. In hierarchical, when you are storing the data into child, then you have to store it in parent node or parent level instance first. But here in network database, you must ensure you know all the parents of your instance that you want to store your data into it. A network database allows flexible relationship model between entities. The following diagram represents a network data model that shows the store entity has relationship with multiple child and transaction entity has relationship with multiple parent entities. Here we have stores entity and here we have transaction entity. Transaction have multiple parents. Also, store have multiple childs. You can say network database model allows one parent to have multiple child record sets and each record set can be linked to multiple nodes. You can say a parent and children. For example, here we have the instance or the table named as stores. Okay, stores have some data of clerks, also some data of customers. Okay, you can take it as the database for a mini market. It also has some managers and also at the same time have some customers. Manager and customers both can do transactions. How? Manager can do transactions in terms of how much sale has been done today. Okay, or you can say your target sale has been done or not. Okay, and customers, they can do unlimited transactions in that stores. Okay,
Yes, sir.
the key advantage is it supports many to many relationship and provide flexibility and accessibility, but not durability. Okay, but not durability. Search result is faster. Okay, why? Because each record has multiple parents and each parent, any parent has multiple child and any child can have multiple parents. So if your search, your desired search or your destination search able to find out the parent, then you can, sorry, then you can find easily the child of it. You just need to find the parent of your destination data. Some popular network databases are integrated data store. Can you give me an example of IDS, integrated data store?
Sir, I cannot hear you.
Sorry, your voice is not good for me.
Uh,
Can you repeat?
I think it is like the data which is connected to each other.
Okay. Any other wants to take part in today's lecture? Guys, share with me, share your thoughts.
Sir, can you please repeat the question again?
Okay. Can you give me an example of integrated data store, integrated DBMS?
So, which is basically interconnected with with each others.
No, no, no. I think you are missing something. Basically, integrated data stores means it is a developed data store. You just need to integrate it with your web app or whatever at which state you want to integrate. Okay. For example, Google has the largest ever big data stores. Okay, so you just need to integrate it with your system. You know that while in machine learning, many data scientists use Google data sets and store in their data stores for training the data, for training the algorithms, for training the robots, for making better decisions. Okay. And the latest example of integrated data store systems are Chat GPT backend system. Okay. Chat GPT use IDS, integrated data stores. That data store is private. Okay. But the data sets are used from the Google stores. Okay. They trained the algorithm while using integrated data stores. Okay. And then they launch Chat GPT. Similarly is the case with Revolve AI. Okay. Integrated database management system are those systems that is pre-built. Okay. You just need to integrate it with your system. Why these are pre-built? Because they can store multiple data tuples in one time. Similarly with MongoDB, but the search result and data training in network databases, or you can say integrated data stores, is much better than MongoDB. Okay, these are some examples. Okay, these are some examples of network databases. Okay, any query?
No, sir.
Okay, for example, I ask in your laptop. Okay, in your laptop you have 1 trillion tuples of data. Okay, and many organizations wants to access this data. Then you can sell it by your own at your own will. Okay, so for example, there is an organization in the world, ABC, that buys your data. For example, organization ABC buys your data. You give your data to that organization. Okay, that organization stores the data into your network database and start training to their algorithms, start training to make something different by using your data. So that data, you can say a data hub. That data is a data store. They just now integrate it with their application and start making things. Okay, so these are the example of IDS, or you can say IDBMS. In IDBMS, you just have to specify the current roles of user, admin, super admin, editor, subscriber, contributor, and viewer. Subscriber is the role that is equally, or you can say just like a customer who is who is paying your data, paying for your data and using your data, but it is hosted at your servers. Okay, they are just renting out your data. They just give rent to you while using your data. Okay.
Okay, sir,
Okay.
I have one question, sir.
Yes, sure.
This data you said just now that I own the data, and if I sell the data to the company, they own the data, or I will still own my data. I have to sell them and give them ownership of the whole data.
Basically
The
in data
data
world.
hub.
Okay, okay, okay. I got your answer. Uh, Basically, the ownership is yours. Okay, you just are giving them rights for using your data, not your ownership. Okay, it is just like this Microsoft software. Okay, Microsoft gives us the product. This is actual product with you can say moving things with some controls that we can use for making our things better and easier. Okay, but the ownership is from Microsoft itself, right? They did not sell us or they did not give us subscription about their ownership. They just give me or the people that need Office, MS Office, their product subscription, their product, but not their ownership. Okay.
Yes, sir.
All right. Okay. Can you please give me an idea which is the best database base for web applications?
MongoDB, sir.
Yes.
They use it mostly nowadays. They use MongoDB. Before MySQL was
Yes.
used a lot. Then I think the Oracle is a company or something. I have no idea about Oracle.
It's okay. You just need to give answer and it is MongoDB. Okay. Explain the different levels of database architecture. Okay. Basically, the architecture, you can say database architecture is the skeleton design. Okay. Just like the human skeleton, it is a skeleton design of your database. Okay. A database architecture is a representation of database design. How your database structure look like, how your database structure interconnected with one another or with one instance to another instance. Okay. How your components of database are connecting and manipulating data with one another. This is how we can translate database architecture. Okay. Types of database architecture. We have some one tier, two tier, and three tier architecture. Basically, one tier architecture is just like mm, you can say, do you know about Microsoft Access database?
Yes, sir.
Okay. While developing forms and dealing with data, what operations are being you are using that operation, how you are using the operations of while dealing with forms and MS Access? Can you explain?
Do you mean to say like how we create the database? How we design the database?
No. Basically, my point is you created a database and now it is fully developed. Now you made a form. Okay. End user interact with that form and submit and retrieve the form according to the requirement. Okay. So
Yes, sir.
what is doing on the back end is actually one tier architecture. In one tier architecture, we just have database and at the screen, at the same screen, we have some form type interface at which we can manipulating data. By manipulating data, I mean we can check, we check by check, I mean we can view, we can create, we can update, we can delete any type of record in the system or in the database management system. This is how our one tier database architecture look like. Okay. In two tier architecture, your database is separate just like front end and back end. Front end gives you one tier. The second tier is your back end. Okay. Your database is operating in the tier 2 architecture and On the tier 1 architecture, your front end is going to deal with end user. End user put some information. That information submit into your database while dealing with proper, you can say, the exact word is protocols. We have here, animation, start annotation. Okay, now check this. Mm, okay, we have, you can say this. This is the screen. The text. Sorry. Mm, this. This is screen input. Okay. And here you input. Here you input. Okay. All right. So whatever the input is here, for example, I put ABC. This is my input. This will directly go into my database with same protocols, just like while we are downloading database. Now, this is how our flow of two-tier architecture of database will look like. Whatever the input you gave on the input screen will directly go with some protocols. Okay, and what are these protocols? I will share with you. With they will go to the into the database. Okay, and while fetching or researching or searching your data inside your database will directly paste onto the user screen with some protocol too. Okay, what are the protocols that I am talking about? These protocols are, for example, if I enter integer type data, then protocol will validize the data that I enter must go into the integer type attribute. Okay, for example, if we have a form and form has some input field that shows enter student roll number, then that roll number will directly go with some validation check that is done by the protocol into the student roll number field inside the database. This is how two-tier architecture will work. In three-tier architecture, we can say our web applications uses three our web applications, you can say Laravel uses three-tier architecture, and its basic is, you can say, MVC. Guys, do you know about MVC?
No, sir.
All right, it's okay. MVC is model, view, and controller. Okay, model, view, and controller. We will discuss it. Okay, this is how our one tier or single tier architecture will look like. The database you can directly You can directly collaborate, or you can directly use the interface of database while doing some CRUD operations. Okay. In two-tier application, we have some front end and back end. Okay. Front end is displayed on user end, and forms or protocols getting the requirements or getting the data and saving it in the databases. At the same time, if client want to search or get display the data on the screen, then he or she can do so by using search query. Okay. On the three-tier architecture, we have some MVC, right? M means model, where our database or models, instances, tables, our data center, our basically we call it as a database or data hub is present. Okay. View means your front end, the presentation tier. Here we have V, client. Client always interact with view. Okay. Whatever client see on the screen, for example, we all are viewing the same screen as I am viewing, right?
Yes,
Yes,
sir.
sir.
We are on the presentation tier. We are on the view tier. Okay. We have some data stored in our hard drive, means on our laptop or in our mobile phone, right? So this is our model tier. Okay.
Yes, sir.
Yes, sir.
Okay. Then what's controller or C tier will do? Actually, C is known as the controller. Controller do some logic operation or do some logical testing on real time while controlling the models and controlling the view at the same time. For example, in the database, at the view end means at the client end, client wants to get display the data of RDBMS class. How many are students, what is the name of students, what are the total marks of students, what are the obtained marks of, and that is the data that is stored at the model in the database of SNIT. Client wants to get display that data over its screen, right? Controller gives the command while receiving the same command from the client. Now controller, okay, controller gives the command to model tier, means data tier. Client wants this type of information. Okay. At the model or data tier means database respond at the same time. This is your desired data. Go with it. Controller controls the data. For example, now check this. We are dealing with front end, right?
Yes,
Guys,
sir.
we are dealing with the front end, means the view. Okay, the view. I want from the Google database, I want to check Wikipedia users or how many users are on Wikipedia. Okay, now I interact with front end means the view. I gave the search command or the search query, and how the search query is formed. Here you can check search question mark. I don't know about the search, but we have a string. means a query. Q means in the link you can check. I request, I have a query, and query is the string. How many users are on Wikipedia? Now you can check. Google search engine said I am sorry. Google controller is sending the command to its database, means model. I have a query that I want to search, and what is the data that needs to be searched? I don't know. And the query is how many users are on Wikipedia. Okay, this is the data value. Okay, this is, you can say, a data address over the internet. Okay, he said, I don't know what is the query. I just have a string. Now you just have to deal with it. Database search in itself how many users are on the Wikipedia. The string is matched and return the view with the address of this query. Okay. Now controller displays the search results of Google databases. Now how controller controls the search results within its database. Controller gives us a variety of options like web pages. We have a web page Wikipedia stats. We have a web page web tribunal. Okay, here we have, so this is the main page of Wikipedia, and this is a web page that is other from the Wikipedia site. So in this way, controller controls how many results should be displayed on the user front end. In this scenario, this is the controller of Google, and Google is an internationally operated software, or you can say a web app inside a browser. So it displays us many thousand, or you can say many hundred of results for its users. Okay, so you can control the results. Also, you can control the input that is getting from the front end to the back end. Okay, MVC is the best example of three-tier architecture. Laravel is the pure MVC framework. Okay, now we can check three-tier architecture is a well-established software application architecture that organizes applications into three logical and physical computing tiers. Presentation tier means user interface. User interface is viewing the screen. Application tier where data is processed, means data, how the data is controlled, which type of data now the process and will get displayed to the user screen. That data tier where the data and its association present for the desired application, means where the data associated with the application is stored and managed. So here we have the application of Wikipedia. I made a request. I want to check the users that is present on the Wikipedia. Controller controls the data, means he gets the input and give it to the backend database of Google. I have a query. I don't know about it, but it is a query for you. You are the database in response with some data with the web address of Wikipedia query. All right.
Yes, sir.
Any question?
No, sir.
Presentation tier. The presentation tier is a user interface and communication layer of the application. where the end user interact with application. Main purpose is to display information. This top level tier can run over the web browser, desktop application, and graphical user interface. For example, web presentation tiers are usually developed using HTML, CSS, and JavaScript, means web pages. Okay. Web pages is also called web presentation. Why? Because it is presenting the content that is present on the page inside your browser. Okay. Desktop application can be written in variety of languages depending on the platform, like C sharp, like .NET, and many other. Okay. Application tiers. Application tier is also known as logical tier, middle tier, and the heart of application. It controls the data in this tier. Information collected in the presentation tier is processed sometimes against other information in the data tier using business logic. A specific set of business rule means you can develop your own controller. Okay, how you want to control your data that is present in the database, and how you want to give a controlled view of your data on the presentation tier. Okay, the application tier can also add, delete, or modify data in the data tier. The application tier is typically developed using Python, Java, Perl, PHP, Ruby on the Rails, and communicates with data tier using API calls. Means using API calls. What does this mean? Okay, this means you just need to develop a code in Python, in PHP, in Ruby, in Perl, in Java. Okay, whenever you write your code, you just make it just like a modular programming, and you just specify the objects that is used to drive API calls. You get your data from front end, stored it into the PHP objects, Java objects, and Python objects, and then send these objects to your database. Database will collect the object's information and respond with some responses. And how you want to control your data of your database, it is totally up to you. These are actually API calls. Okay.
Yes, sir.
Yes, sir.
All right. Data tier means backend of your application, your data center, you can say a database. Data tier is sometimes called database tier, data access tier, or backend is where the information processed by the application is stored and managed. This can be relational database management systems such as PostgreSQL, MySQL, MariaDB, Oracle, DB2, Informix, Microsoft SQL Server, or in a NoSQL database server such as Cassandra, CouchDB, or MongoDB. Okay, no, what is NoSQL? Do you know about that,
No, sir.
guys? Okay, basically it is the you can say anti of SQL. SQL have some queries while development of the database, but in NoSQL database, we store our data in the form of files. Okay, not in the form of tuples. Okay, by term
Sir,
of tuple. Yes, sure.
you said NoSQL is opposite of SQL. Is MySQL and SQL same? Both of them?
Probably it is same as 98%, but sometime MySQL and SQL different behave differently, and it is only because of syntax. How we write the code means the queries in the MySQL and SQL. Basically, SQL has very much and extensive variants like MySQL,
MySQL Lite, Microsoft SQL Server, Oracle. These are all using MySQL queries, but in different syntax. Okay. So whatever the behavior, we don't, it is not the matter. The basic point is our data will get stored in the data tier, and we call, okay, whenever we call the respective data, the corresponding data will be appear on the front end. Okay.
Yes, sir.
Your main thing is your data must get stored into your database. It doesn't matter while you are using MySQL, SQL, Oracle, Microsoft SQL Server, okay, or MongoDB, CouchDB, Cassandra, whatever the database you want to use, you can use it. But while dealing with the fact of fast, reliable, durable, and many other things that you want to incorporate into your database management system, then you must keep in mind your selection must be standardly following your options or your covering your needs. And I think so MongoDB is the most powerful, most fastest, durable and reliable database. Then if you don't want to use it, then it is totally up to you. Then you can use MySQL. If you want to use MySQL Lite, then you can also use it. Okay.
Yes, sir.
Okay. In three-tier application, all communication goes through application tier. The presentation tier and the data tier cannot communicate directly with one another. Why? Because they will show, means data tier can show uncontrolled data over the screen. Basically, the controller mission is to control the data, what you want to display on the user end and what you don't want to display. For example, you do not want to give display to your user. For example, you do not want to give the outlook of your database structure. For example, you do not share the sensitive information that is stored over the database of your application. Okay, so whenever you do not want to share these type of things across the browser or across the front end, then you have to use controller into your database management system. And whenever controller comes into the tier of DBMS, the tier will automatically convert into three-tier database management system, three-tier architecture. Okay. Okay, we will discuss data models afterwards. If you have any query, then you can ask till now. Any query, or you wanna share your thoughts with me, then you can do so.
So far no queries. So if there are any in further, can we text and ask?
Yes, you can ask your queries anytime.
Sir, I had one last question.
Share with me.
Like you said, the data will be stored. Is it stored in the front end or back end, or there is some other space between? Like I'm confused in this one.
Sorry, data is stored at which end?
You said like data will be submitted by the user and it will be stored somewhere. Like where it is stored in the front end itself, or it will be in the back end.
No, 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 no. Basically, user is interacting with front end, right?
Yes, sir.
Just like I interact with the Google Chrome browser. I input mm, Wikipedia. Okay. Now I input some information into the input. Okay. When I hit enter, controller take my input and process. What is the input? Controllers understand that it is a search and it is a of my query of my end user. Okay. And in query, I have a query. Query is Wikipedia. It sent this query into database means backend. Database perform action and respond with some data. That data comes with some web address. Here you can check Chrome has some web address. Okay. And source ID is Chrome. UTF is 8. UTF is 8 means this is a responsive window. Responsive window means, for example, if you by means of UTF-8, it means whenever you shrink your screen, the data that is present in the screen will be responsive. Will be responsive means will act as screen gets shrinker. Will be the same data. Just give me a second. Okay. Now responsive in iPhone 12 Pro screen. Is it the same data that is appear in the okay. Now is it the same data that is appear on the desktop screen, right?
Yes, sir.
So basically the UTF is this. We use UTF for responsive screens. Okay. And we have some web address. Source ID is Chrome. It means we are using Chrome. And we have search query of Wikipedia. Whenever whenever query, or you can say end user generates some request, it will go on the back end while dealing dealing by controller. Okay. Is it good now?
Yes, sir. I got it now, sir.
Okay. Thank you. Thank you for your time. Take care. Allah Hafiz.
Sir,
Yes.
there was a question I wanted to ask you. Here, I made this diagram for the assignment. Is
Okay.
this correct? How do I explain the relationships that I made, like the connections that I made? How do I explain these? Like, for
Okay.
example, in the question, it was like you have to explain the relationships that you did. So, how do I explain them in words?
Okay. Now your relationship line have some straight line, and at the other end you have some crow foot lines, right?
Yes.
Crow foot lines means many relationships. Okay.
Can I make a note here? Yes. Sir, is this like basically correct? Like, does this satisfy the question's criteria?
The question that you ask from me
Yes.
doesn't meet the criteria. Why? Because the question is what is the relationship type, right? And
Yes.
how you can explain the relationship type that is present in this type of in this diagram. Now you have to write your answer according to the question. The question is Type means type is one to many, just like customer has one customer means primary key. It is connected with primary key, right? Customer ID.
Yes.
Customer ID is acting as a foreign key in the sales. Okay. And it is saying means according to your screen, you wanna say it has customer one customer has many sales. Okay. One customer has many sales. Why? Because customer can buy many products, right? Customer can buy single product and at the same time many product from the same shop. In this way, the sales data has been generated, right?
Yes.
Okay.
So, just
Right.
one thing I want to
Yeah,
ask.
sure. Sure,
Like,
sure.
for example, here in the table of content, over here, they asked us to produce design documentation, EDR normalization, and for this, and then in the activity 3, they asked us for, like, sorry, they asked us for, like, we have to explain the relationship models in the between, the one we did it from activity 2, right?
Okay.
So for activity 3, like I try to sorry, they're just a little disorganized. But like for example, in activity 3, here I tried to explain the relationship models, but I just went simple with it. Like as in I just gave the definitions, the easy definitions of them. So should I change that and explain my relationships, the one I made it?
Sorry, I can't understand your question.
In activity 3, over here, this part,
Mm,
they asked us to explain the relationships at the end. Even
okay.
earlier in, I think, level, activity 1, they asked us about relationships and everything, so we explained in activity 1 as well. But in activity
All
3,
right.
producing the report, they're asking us to explain again. So in activity 3, are we supposed to explain the ones we made in the picture, or from one to many, many to one?
Okay. You want to describe relationship model, right?
Yes.
All right. Do you know about what is relationship model? If not,
Yes.
then I will. Okay,
Yes,
okay.
like this is relationship model, right? EID basically. These are the connections, the relationships you make
Yes.
between the batches.
Basically, models are the tables, and whenever they are connected with some relationships, these are called relationship models. So then you can write or you can inform or do you can deal with this question like in relationship model we have a customer table and it is connected with sales table with its primary key as a foreign key in the sales table. Okay, both tables have one to many relationship towards sales. One customer can hold multiple records in the sales table at the same time. One sale, okay, one sale is connected with the batch of honey. I think so.
Mm, yes, the
Okay,
sales is connected to batches.
means the product one customer buy multiple products at the same time or single product at the same time depending upon the quantity. Okay, and honey also have some batch identity, product identity, and the type. So in this way you can explain the entire model based on the relationships. Honey and hive have one to one relationship. Basically, you can collect multiple type of honey from multiple hives. Okay, but that relationship stands from many to many. That is, I think so, is not good for our database, data modeling. Sorry. Okay. So we should convert it one to one or one to many. So here
Then
we have one to one, then it is also true. Similarly, at the same time, we have another table, another instance, honeybees. Honeybees, okay? Honeybee can have multiple hives, okay? But one hive hold multiple
multi-
honeybees, okay?
is there any fault in this particular relationship? Because if there is a mistake in this, I'll have to carry it forward to the next table as well. Like during normalization, I'll have to open it as well. So is this correct?
Just give me a second. The connection that you have done from sales to batch of honey is not good. Okay, this is now you
This one?
have to, yes. Why? Because it is not dealing with some standards. Okay, you
Okay.
cannot you cannot interrelate one connection to another. Okay, for example, if you want to connect product ID with the as a foreign key in the batch of history, then you can do so, but you have to make separate lines. Okay,
Sir, is it possible for you to draw on my screen if it is possible for you?
no, because your screen is in your control and my screen is in my control. You just have to make the connection lines separately from the sales
This one,
outgoing lines.
right?
Yes, yes. You have to make a separate connection line from where you join sales to honey. There is a middle joint. Okay.
Yeah.
Yes.
So, sir, should I make like two separate lines? One from
Yes.
and then another one from the same.
Yes.
Okay.
Okay.
Okay. Are the rest correct?
And how the type of honey will act as a foreign key, because for foreign key, candidate key, primary key, another is a unique key. They must be uniquely identified. Okay, they must be uniquely identified, just like the ID number, just like the registration number of students, just like the resident number inside the country. Okay, so type, I don't think so is a foreign key, but type can act as a composite key if you join two primary key or a foreign key. Okay.
So, composite key does not play a role in any relationships.
Uh, composite key, we can develop composite key if needed. Okay, but in ordinary situations or in the regular situations, we just take over with primary key and foreign keys. If sometime we can use unique key also, but composite key makes our instances and relationship complex and data redundant. Okay, so I don't think so type is a foreign key.
Okay.
Okay, and also type is a foreign key in honey also. So there should be one primary key and there should be one foreign key. Okay, in each table. Your table must be normalized.
Yeah. Sir, I had a problem with normalization as well.
Okay, just think in mind breaking down large table into small pieces while dealing with their IDs. Means while connecting with their IDs. Okay.
Like for example, we had here's are some of the tables that I made. Like it's I'm so sorry, it's so disorganized right now. Like this was the
It's
sales
okay.
table, uh, and this was the hives table, I think, and then the honeybee table, like here.
Actually,
Yeah, I will organize it and then I will try to ask you in a proper way.
okay, no issues. Actually, let's take an example of student. Okay. I will elaborate it verbally. Student have some ID, means record ID, tuple ID. Okay. Okay.
Okay. Yes.
S ID, S name. Okay. S registration number, S email, S age. Okay. S country, S city. I think so. These are 8 attributes, right?
Yes.
Now break this entire instance, means table, into 3 normalizational forms. How? SID will remain same, S name will remain same, and the third one was S email. Okay.
So for example, here I try to make of this table basically. One second. Yeah, this table I try to normalize it here. Is this okay?
Honey, price, order, placed, payment. Basically, you are displaying me table and the attributes, right?
Yes. Mm. All the here's the table and the attributes. So
You
from
will
this,
be, you will get confused. You now check this. For example, we have a student table. Student, okay.
yes.
Student have some s s dot id, s dot name, s dot email, email, s dot age, s dot registration number, okay, and s dot mm, semester. Let's say it's a semester, okay. I'm just using the attribute of semester. Okay, semester and s dot
Subject.
s s dot
The subject.
city. Sorry. S dot subjects. Sorry, we cannot add subjects right now. S dot country, name, email, age, registration number, and s dot fees. Okay. 1 2 3 4 5 6 7 8 9 3 3 and 3 9. Okay. Now this is the regular table. Okay. Regular table structure. Okay. Now normalize it. How we can normalize? Normalize first normal form. Okay. 1 NF is equals to S dot ID. Okay. S name, S email, S dot age, S dot bridge number. Okay. This will be the first normal form, first table. Now in second normal form, sorry, in first normal form, the second table, the rest part of table will be s dot id. Why? Because we are connecting sid with the second part as in foreign key. Okay, with one-to-one relationship. S dot id s.
Just basically, we will break the main table in
Yes,
first
we
conversation.
should we should break the large table into small tables. Okay, id s dot semester, s dot city, s dot country, s dot fees. Okay, now this is our first normal form. SID is connected with SID with one-to-one relationship. Okay, now second normal form, second NF will be S dot ID, S name, S name, S email, S age. Second one will be S dot ID, S dot semester, sorry, S dot registration number, S dot semester, S dot city, S dot country, and S dot fees. Okay. In third normal form, sorry, third NF.
So in the second normalization, we're basically breaking the first normalization table, right? We're just reducing that.
Yes, we are reducing one NF.
Yeah. Okay.
Okay.
Okay. Yeah.
Then in 2NF, we will break this. How? S dot ID,
Name and
S
email
S name, S name,
and
S
email.
email. Then S dot ID. Okay. Now
Yeah.
take a very careful look. S dot registration number, S dot age, S dot semester. Okay. Now S dot registration number as a primary key for the next table, but as acting as a foreign key for second table. Registration number, S dot registration number is the foreign key for this table and primary key for third table. Okay.
Okay.
Now semester is done. Now we will check S dot city, S dot country, S dot fees. Okay. Here you can check. We have done primary key concept, we have done foreign key concept. We can access from primary key and foreign key as well. Why? Because registration number must be unique identifier. Foreign key and primary key must be unique identified throughout the table, throughout the instance. Okay, and we can also develop the relationships that is based on the primary key in the next table but foreign key as in the previous. Okay, this is the primary key in the next table, but acting as a foreign key.
In the other table.
Okay.
Okay.
Now
Yes, sir.
check, we have done breaking down this large table into small table. 1, 2, 3, 1, 2, 3, and 4. Basically, we have three entries. The first is identifier. Okay. Similarly, in the next one, we have three entries. The first is identifier,
Sir,
right?
for the ID will be in all the tables.
Yes, not ID. It is the identifier that is unique and can hold one-to-one relationship, because every table or every instance hold one record in the whole table, means redundant data. There should be one data present across the table.
Okay.
There is no duplication of data. For example, if a student name as Mujahid comes with the same ID that is present inside the table, and that ID is 15. Okay, let's say we Mujahid has some ID 15. At first, SQL check if we have student ID that belongs to 15 is present, then it will not store that data, or it will check if there is some attribute that is empty inside. For example, the attribute number S semester, Mujahid semester is missing, and the incoming ID holds the data for semester, then SQL override S semester by empty to semester name or semester number. For example, he want to save semester number 7, then SQL override 0 to 7. Or if he want semester name, for example semester RDBMS, then if there is something present or not present, then SQL override it to semester RDBMS. Is that good now?
Yes, it is. Thank you.
Any query?
No, sir. Thank you so much.
All right. Take care. Allah Hafiz.
Allah Hafiz. Thank you.